Part A. Find the equation of the normal to y equals 1 over x at x equals 3 over 2. So we need to find the normal to the curve at a point, but the normal is defined as being perpendicular to the tangent to the curve at that point. The point in question is given by x equals 3 over 2, and we call the tangent to the curve at that point t, and we call the normal to the curve at that point n. Now t and n are perpendicular, so their gradients satisfy the equation mt times mn equals minus 1, where mt is the gradient of the line t, mn is the gradient of the line n. mt is given by dy by dx evaluated at x equals 3 over 2, which is d of x to the minus 1 dx evaluated at x equals 3 over 2, which equals minus x to the minus 2 evaluated at x equals 3 over 2, which is the same as minus 1 over x squared evaluated at x equals 3 over 2, which finally turns out to be minus 4 over 9. And since mt times mn equals minus 1, then we find that mn equals 9 over 4. So the line n has the equation y equals 9 over 4x plus c, and it goes through the point P1, here in green on the graph, and P1 also lies on y equals 1 over x, of course. We now have to find the value of the constant c. And since we know that P1 lies on both the line n and the curve y equals 1 over x, if we find the coordinates of P1, we can substitute them into the equation y equals 9 over 4x plus c to find c. Now, P1 has coordinates 3 over 2y, where y equals 1 over 3 over 2, since P lies on y equals 1 over x, and so y equals 2 over 3. So we substitute the values for x and for y into the equation for n to find that c equals minus 65 over 24. And so the equation of n is y equals 9 over 4x minus 65 over 24. Part B. Find the coordinates of the point where this normal crosses the curve again. So we need to find the coordinates of point P2, shown here on the graph, and to do so we solve the simultaneous equations y equals 1 over x, y equals 9 over 4x minus 65 over 24, with the condition that x must be less than 0. We immediately have that 1 over x equals 9 over 4x minus 65 over 24, which, after some manipulation, gives us that 54x squared minus 65x minus 24 equals 0. Now this quadratic looks slightly forbidding, but it turns out that both 54 and 24 have relatively few factor pairs, as we can see here, and we quickly find that the factors 27 times 2 and 8 times negative 3 allow us to factor the quadratic as 27x plus 8 times 2x minus 3 equals 0, to give two possible solutions: x equals minus 8 over 27 or x equals 3 over 2. But bearing in mind that x must be negative, we take the solution x equals minus 8 over 27, and from x equals minus 8 over 27, we find that y equals minus 27 over 8, so that P2 has coordinates minus 8 over 27 minus 27 over 8.